Hi, this is Mary, and this is another magical math moment. This video is geared for Algebra 2 students. We're going to look at simplifying radical and rational exponent expressions. So there's a lot going on here. This is going to be kind of long, and feel free to pause as you go through this, okay? We're going to use our basic laws of exponents to kind of simplify some things, and then we're going to be applying those to more challenging problems. In our first one, we're multiplying x to the second times x to the third. And you probably remember to keep the base, which is x, and add the exponents, 2 plus 3. So our answer will be x to the fifth. When we are dividing with like bases, keep the base and subtract the exponents. So in this case, x to the 7th divided by x to the 4th is x to the 7 minus 4, which simplifies into x to the 3rd. When you have a power to a power, you're going to multiply those exponents. So keep the base x. If we have x squared to the 3rd, we're going to make that x to the 2 times 3, which is x to the 6th. And then finally, x to the negative 5. Remember, this is the same thing as x to the negative 5 over 1. And whenever you have a negative exponent, you've got to move it. So if it's on the top of the fraction, it's going to go down to the bottom. And when it does that, the exponent changes sign. So if it's negative up here, it's going to move down and become positive. So x to the negative 5 is going to become 1 over x to the positive 5. Similarly, if you start with something like 1 over y to the negative 3, you're going to bring that up, and it'll become y to the positive 3. Okay, let's apply this to some uglier looking things. We've got 3 to the 2/3 times 3 to the 1/6. Keep the base 3, add the exponents. 2/3 plus 1/6. I've got to find a common denominator, so I have 2/3 here. I want to convert that into sixths, though. I'm getting ahead of myself. 3 goes into 6 twice. 2 times 2 is 4. So I have 4/6 plus 1/6, which is going to give us 3 to the 5/6. And that's it. That's where you stop. That's not so bad. Over here, I have 5 to the 3/4 divided by 5. That's just like 5 to the 1st. So I can rewrite this using any form of 1 that I want. So why not make this 5 to the 3/4 divided by 5 to the 4/4? Keep your base, subtract your powers. 3/4 minus 4/4 is 5 to the negative 1/4. Now you all know from our discussion up here, we can't leave a negative exponent. So we're going to say 1 over 5 to the positive 1/4. For our purposes, we're going to leave that. This really represents a radical in the denominator, which is usually not acceptable, bad math etiquette, but for our purposes right now, we're just learning how to simplify. We're going to leave it alone. All right, look at this monstrosity. 4 to the 2/3 divided by 10 to the 2/3 raised to the 6th. Look to see if you notice anything interesting. I'm observing that these are both going to the 2/3 power. So I'm going to kind of like factor these out. I don't know if that's really the best way to say this. So this becomes 4 over 10 to the 2/3 to the 6th. So we're going to go ahead and reduce this fraction now to 2/5. Power to a power, multiply. If I put 6 over 1 and multiply across, I get 12 divided by 3, which is 4. And again, for our purposes, we're just playing with laws of exponents. I'm going to leave that alone just like that. If we're trying to simplify radical expressions, you probably remember with square root that we look for pairs. So if I break this down by finding two factors that will give a product of 240, I might choose 10 because I see this ends in a 0. So I would do 10 and 24. I can break 10 into 5 times 2. And I can break 24 into 2 times 12. I can keep going with this and break 12 into 4 times 3. If I go a little bit more, I'm going to go ahead and get 2 times 2 here. So I circle my pairs, 2 2s, 2 2s, and I box in anything without a partner. I'm going to take 1 from each pair out and multiply them outside of the radical. The two numbers that have no partner will stay in and they will be multiplied. So our answer for this is going to be 4 rad 15. Some people say it as 4 root 15. You can do that if you prefer. It's up to you. And hopefully that makes some sense here for you, okay? All right. If I'm looking at the cube root of something, the process is similar where I break down factors, but instead of looking for pairs, I'm looking for trios this time. So if I have 135, I notice that's divisible by 5, and I get 27, which is fantastic because that is a perfect cube. So I have my 3 3s and a 5 left over. That means my simplified answer will be the cube root of 5 with one of these 3's outside. So 3 times the cube root of 5, and that's that. We can also do this with variables. So if I have 1800, x to the 7th, y to the 10th, z to the 3rd, I'm gonna do what we've been doing. I'm seeing 100 here as a factor. So if I divide 1800 by 100, I get 18. The 100 is nice because this is 10 times 10, there's one pair. 18 can break into 2 times 9. 9 is a perfect square. So I know that the numerical piece of this is going to be 3 times 10, or 30, and then I'm going to have the square root of 2. Now the next part of this involves the variables. So I'm going to take these variables and divide by this second root. So for x to the 7th, I'm going to divide 7 by 2. And think about like old school elementary division, right? This would go in 3 with a remainder of 1. The number that you get out here, your quotient, if you will, that's going to be your power of the variable outside the radicand. The 1 represents the power or the exponent inside the radicand. So x to the 7th, when we take the square root, is going to give us x to the 3rd outside, x to the 1st, or just x inside. We're going to repeat this process with y to the 10th. 10 divided by 2 is 5 with no remainder. That means I have a y to the 5th outside. I have no y at all inside. I can say y to the 0, but that's really just the same thing as 1. So why would I write that? 0 to the 3rd. I'm sorry, 0. Z to the 3rd. 3 divided by 2 is 1, remainder 1. That means a z outside and 1z inside. So your final answer, 30x to the 3rd, y to the 5th z times the square root of 2xz. Let's look at one where it's cube root. It's going to be kind of the same thing, right? So I'm going to try to break down 1125. I see the 5 at the end, so I'm going to try 5 with 225, and look at that. That is going to break into 15 and 15, which would be nice if this were squares, right? But these are cubes. So now we got 5 and 3, 5 and 3. If you find different factors, that's totally okay. We're still going to get the same thing. So let's see. I've got a 5 and a 5 and a 5. So I know one of these 5s comes out. 3 times 3 is 9. So I'm going to have the cube root of 9 as part of my answer. We're going to do what we did with the square root, but this time we divide by 3. So x to the 9th, I take 9 divided by 3. That gives me 3 remainder 0. So x cubed comes out. I'm going to look at y to the 8th next. 8 divided by 3 is 2, remainder 2. So we'll have a y squared outside and a y to the 8th inside. Z to the 14. 14 divided by 3 is going to be 4, remainder 2. So we have z squared outside, z to the 4th outside. I'm getting carried away again. Z squared. There we are. Okay. Now we've got to do some rationalizing. So we have the 4th root of 2 to the 5th. To rationalize, I need to make sure I have a grouping of 4 of the same thing. So when I do this, I'm going to multiply both the top and the bottom by the same thing. I have 1 5, I need 4. That means I need to multiply by 3 5s down here. What I do to the bottom, I have to do to the top. So we're going to have the fourth root of 5 times 5 times 5 times 2. 2 times 5 times 5 times 5 gives me 250 up here. And then on the bottom, the fourth root of 5 times 5 times 5 times 5 is just 5. That's it. That's all you have to do. All right, so just be careful on that. Does it get sneakier? Of course. If we've got something like 4 over 2 minus the square root of 3, we're going to multiply by the conjugate of the denominator. You might remember this from complex numbers. So conjugate just means you copy it and change the middle sign. From there, we're going to go ahead and distribute in the 4. So 4 times 2 is 8. 4 times rad 3 is 4 rad 3. When you're multiplying a binomial times its conjugate, you fluh. So 2 times 2, 4. Negative rad 3 times positive rad 3 is going to be negative 3, which ends up being 1. So our answer is just 8 plus 4 rad 3. All right, the final example is similar. So we're going to multiply by the conjugate, 5 minus 2 rad 6 over 5 minus 2 rad 6, the conjugate of the denominator over itself. On the top, we have to FOIL. So we're going to go 1 times 5 is 5. 1 times negative 2 rad 6 is negative 2 rad 6. Rad 7 times 5 is 5 rad 7. Rad 7 times negative 2 rad 6 is negative 2 rad 42. All right, on the bottom we fluh. 5 times 5 is 25. Positive times negative is negative. Now be careful. 2 times 2 is 4. Rad 6 times rad 6 is 6. This is going to give you 25 minus 24 on the bottom, which is 1. So all you have to do is clean up the top. Yeah, there's nothing to clean up, so we're just going to leave this alone. And as disgusting as it looks, that's the answer. So I hope that you have enjoyed this video. I know it was kind of quick. I didn't want to go too long with this, but we're at about 12 minutes here. So I hope that you've enjoyed all of the different topics, and please feel free to share this video out with your friends, and I appreciate any likes and subscribes you want to give to the channel as well. I'm Mary. This has been a Magical Math Moment, and I'll see you next time. Bye.